Wellbore excavation is begun in a variety of ways. The method for spudding in is dependent on a variety of factors, such as the type of well, water depth, seafloor terrain, soil competency, and local experience. A structural steel casing is installed first, which keeps the excavated wellbore from caving in, provides a means to re-enter the wellbore, and serves as a foundation upon which future casing strings and heavy seabed equipment will be loaded. For purposes of this demonstration, all future casings and drill hole diameters will reference a 30-inch structural casing, and this casing will be jetted into place as opposed to cementing it into a pre-drilled 36-inch hole. As shown, the structural casing is run with a permanent guide base, or PGB, attached to its top joint. In this example, an accessory temporary guide base, or TGB, will be run simultaneously with the structural casing and slung below the permanent guide base. When run this way, the temporary guide base will provide additional load-bearing capacity if the structural casing subsides into the seabed enough to allow the PGB's gimbaled bottom to contact the TGB's top funnel. The large surface area of a standard TGB will provide increased load-carrying capacity to help support the subsequent casing strings. In the event of contact between the PGB and TGB, the rounded gimbal compensates for a sloping seabed. The temporary guide base can alternatively be set on the seabed before installation of the structural casing begins, particularly if a hole is to be drilled first. The temporary guide base in that scenario may keep the initial drill bit from skidding on a firm seabed and will make re-entering the wellbore with a structural casing much easier, particularly in areas with strong currents. Whether jetting the structural casing into place or running it into a pre-drilled hole, the casing and PGB system are installed using a running tool connected to a running string of drill pipe. For jetting operations, the casing is lowered into the seabed while seawater is pumped from the drilling vessel through a drill string that is installed inside the casing down to a jet head, positioned a short distance from the bottom of the casing. As seawater exits the nozzles or jets of the jet head, the soil core accumulating inside the casing pipe is flushed upwards through the annulus between the drill pipe and the internal diameter of the casing. The circulation stream exits the top of the casing and is dispersed into the area around the well. It is critical to control pumping velocities and penetration rates so that the flow does not broach the casing shoe and flow up the outside of the casing. Since a jetted string of structural casing is supported solely by the friction of the seabed layers, the broaching of the casing shoe could result in a less stable foundation. During jetting operations, progress and inclination of the casing is continually monitored by the ROV camera. The signals are transmitted via an umbilical cord to the surface vessel, where the images are displayed on a TV monitor located near the driller's console. Once the structural casing is jetted into place, the casing can be left to soak in place for a few hours. This allows the seabed formations time to expand and adhere to the casing. Verification of wellbore stability is accomplished by a gentle pulling and pushing of the drill pipe and running tool. After wellbore stability is verified, the running tool is released and the jetting assembly is retrieved.